Welcome to today's lesson over polynomial functions. We will begin in topic 1 with some terminology. Let's look at number 2. We need to fill in the table, and the table asks for us to begin by writing this polynomial in standard form. To do so, this would be written in also descending order. Our highest term, based on the exponent, would be the term negative 2a to the fourth. After that, we would write minus the a cubed, followed by the positive 3a, and last but not least, the constant 6. This is considered standard form. The degree of this polynomial is based on the highest exponent on the variable a, which is a 4. So this is a fourth degree polynomial. This is really important, the degree of the polynomial, as we study this chapter. The leading coefficient is the first term in our polynomial written in standard form. The sign of the leading coefficient is negative because it begins with a negative 2. This is also an important piece of information. The parity of the polynomial is extremely important as it relates to end behavior. The parity refers back to the degree of the polynomial. A fourth degree polynomial means it is an even parity polynomial because the number 4 is an even number. If we look at example 3, the parity is 5. 5 is an odd number, therefore the parity is odd. The parity will lead us into end behavior. End behavior for an even degreed polynomial could either be down, down, or up, up. The end behavior for an odd parity polynomial would be either down, up, or up, down. These end behaviors become very important as we progress through this section. Let's scroll down and look at the next topic. We are now asked to solve by factoring. We're going to solve by factoring. In order to do this, our equation must be equal to 0. So be sure that every equation is equal to 0 before you try to solve by factoring. Number 8 does not equal 0. So we need to require it or change it so that it equals 0. I'm going to add 20y to each side of this equation. It will say 2y cubed plus 14y squared plus 20y equaling 0. Once my equation is set equal to 0, I then factor. This has a greatest common factor of 2y, leaving behind a y squared plus 7y plus 10. Now I want to factor that trinomial into y plus 5 times y plus 2. Once your polynomial is in factored form, set equal to 0, we then set each factor equal to 0. 2y equaling 0, y plus 5 equaling 0, and y plus 2 equaling 0. We then solve and get 3 solutions. Those 3 solutions are y equaling 0, negative 5, and 2. The next page leads us into end behavior. Here we look at number 12. Number 12 is already set equal to 0, but it is not factored. When you have a 4-term polynomial, you want the middle term to always be a plus sign. So instead of minus 9y, we would rewrite this as plus a negative 9y. Then we would group, meaning we would put parentheses around the first two terms and parentheses around the second two terms with the plus sign in the middle. We would then focus on the first two terms, taking out a GCF of y squared. The second two terms, we would take out a negative 9. Once this is done, we then can factor it into y plus 5 times y squared minus 9. The y squared minus 9 is a difference of perfect squares, which we'll factor one more time. Once we have the polynomial fully factored, we set each factor equal to 0. This will result in 3 solutions. As we continue, we will move into these graphs, which will take us into end behavior. As mentioned earlier, if you have an even-degreed polynomial or even parity, you have two options for end behavior, either up, up, or down, down. If you have an odd-degreed polynomial, which is odd parity, your end behavior will be two options, down, up, or up, down. Looking at these blue graphs, you can see on number 13, the left side of the graph is going down, and the right side of the graph is going up. Therefore, our end behavior would be written as down, up. Now, this is a very informal way of writing end behavior. A more formal way of writing this end behavior would be written as below. When the left side is down, it's written as x approaches negative infinity, that's your left side. Your y value is going down, which means y approaching negative infinity. As on the right side of your graph, it is going up. So the right side is written as x approaching positive infinity, and the y value is going up, which means positive infinity. Our second example, looking at the graph, you will see the left side is down and the right side is down, or down, down in behavior. More formally, this would be written as left side is down, meaning as x approaches negative infinity, y is going down, or y would approach negative infinity. The right side written, right side is down. The right side is as x approaches positive infinity, y is down, or y approaches negative infinity. So all of the wording with infinity is the formal way of determining the end behavior as being down, down, or down, up, or any of the 4 options for end behavior. As we move on to our connection to college algebra, we are looking at a function here which is a 5th degree polynomial. It begins by asking me for the zeros and their multiplicities. To find the zeros, I set the polynomial equal to 0 and factor it. This polynomial has a factor of x to the 4th. Once it is factored, I set each of the factors equal to 0 and solve for my zeros of my polynomial. These zeros are also known as x-intercepts. Now the multiplicity is based on the power in the factored form. So When x is 0, it is coming from my x to the fourth term, which is a multiplicity of 4. The x value of negative 2 is coming from the x plus 2 term, which is to the power of 1, which represents a multiplicity of 1. Multiplicity of 4 means that the behavior at that x-intercept will be tapping that x-intercept. A multiplicity of 1 means at that x-intercept negative 2, 0, I will cross. Part B asks for the y-intercept. The y-intercept is the point which occurs when the x value is 0. So returning to my original polynomial, if I replace my x values with 0, I will determine that the y value will also be 0 at this point. So the y-intercept is the point 0, 0, also the origin. The end behavior is based on the parity. We refer to the degree of this polynomial as a fifth degree polynomial, so it has odd parity. Therefore, the end behavior will either be up, down, or down, up. Since my leading coefficient is a positive 1, my end behavior informally would be written as down, up. Now to sketch this graph, I would begin by plotting all of my x-intercepts, my zeros, and my y-intercept. Well, I have a 0 at the origin, which is my x and my y-intercept, and I have a 0 at negative 2, which is just an x-intercept. I wrote above that at the negative 2, 0 point, I will cross based on the multiplicity of 1. With my end behavior down on the left and up on the right, I will be coming up and crossing that 0, or that x-intercept. At the origin, because the multiplicity was 4, I will tap that x-intercept, or bounce off of it. So I come down and bounce off, which makes the end behavior as prior determined to be up. This is my sketch of my graph. I could use a calculator to determine just how high this graph goes between my two x-intercepts, but this is good for a sketch. Turning points are again based on the degree of the polynomial. We stated that the degree was a fifth degree polynomial. This tells me that the maximum number of turning points would be 4. We only have 2 turning points, which I will indicate with a red X. This is a turning point, and this is a turning point where the graph turns from increasing to decreasing and decreasing to increasing. So again, there's a maximum of 4 turning points, meaning there could be 4 or 2 or fewer, but in this case there was a maximum of 4 predicted, but reality was I only had 2. I do hope that you have learned from this recording and it can better assist you in your college algebra class.